Bismillahirrahmanirrahim. Assalamualaikum and good day, everyone. Now, today we're going to continue morphological image processing to the second part, which is fundamental operations, namely erosion and dilation. So, in morphological image processing, the operation involved is very similar to spatial filtering. We know from previous lectures that we have learned spatial filtering. Spatial filtering requires mask which run across or move across the image and change the value of the image accordingly. For instance, we have learned how average filtering mask done its job, and then we have other masks as well, like Gaussian masks and etc. And similarly, morphological image processing operations works very similar to spatial filtering. The structuring element is moved across every pixel in the origin image to transform it to a new process image that have new pixel values. So this sounds very similar to spatial filtering. The value of this new pixel depends on the operation performed, and there are two fundamental or basic morphological operations, namely erosion and dilation. So what is erosion? Erosion, okay, in a simple term or simple terminology, is actually removes pixels on object boundaries, whereas dilation adds pixels to the boundaries of objects in an image. So they works in the opposite way. The number of pixels added or removed from the objects in an image depends on the size and shape of the structuring element, which we have learned before. And we know that this structuring element, OSC, can have many forms, from squares and then to cross, to diamond shape, to lines, and etc. Mathematically, erosion of image F by structuring element S can be expressed by F minus circle S, or F eroded by S. The structuring element S is positioned with its origin at xy, and the new pixel value is determined using the rule. The output is the new output or new pixels is gxy. Okay, gxy becomes 1 if S fits F, but gxy becomes 0 if other than that. Okay, here we will look at an example on how erosion works. Okay, we have an original image on the left with object pixels in dark, okay, in dark color, and we will do erosion operation, and the result will be produced or given, okay, into the right image, okay, or right space. So what will happen when we do erosion on the original image? that contains the objects given by the dark pixels. And in this case, the structuring element is the plus, is the plus structuring element given as, okay, the one below here. Okay, now start. Okay, we start by putting the center of the structuring element on the first top left corner pixel of the origin image. Okay, now we have a miss, so we put 0 here. Miss again, miss again, miss again. Sorry, this time we have hit, but still 0. Hit 0, hit 0, miss 0, miss 0. Again, miss 0, miss 0. Now we have hit still 0, hit 0, hit 0, hit 0, hit 0, miss 0, miss 0, hit 0, hit 0, fit 1, fit 1, hit 0, hit 0, miss 0, hit 0, hit 0, fit 1, fit 1, hit 0, hit 0, miss 0, and 0 again. Hit 0, hit 0, fit 1, hit 0, hit 0, miss 0, miss 0, miss 0. Hit 0, hit 0, hit 0, hit 0, hit 0, miss 0, 0, and 0, and the rest are all 0. So we have only 1, 2, 3, 4, 5 object pixels, or on pixels, or pixels with number 1 in the process image. So when we transform this into a dark pixel, what happened? So we'll have like this. So we have 1, 2, 3, 4, 5. Okay. Newly processed image, which we can clearly see that it already shrink from the original image. So this is the effect of erosion to an object in the original image. And here are some examples of where we can see the difference, or the different effects of erosion when using different size of structuring elements with the square shape. So we have here the original image, and then erosion by 3 by 3 square structure element. We have result here, and if we use 5 by 5 structure element, we have the result here. So the result, the shrinking or the eroding, is much more obvious when we use a bigger size of structuring element. Okay. And of course, in these examples, 1 refers to black pixel. So the objects is black. Now let's look at this example of erosion. As you can see, okay, the origin image. Okay, this time consider the image have objects which is in white. Okay, the object is now in white and the background is black. So we expect that when we do erosion, the white will be shrinking. Okay, so when we implement erosion with a disc shape of radius 10, so what will happen is, okay, you can see the effect on the top right here, and as we expected, the white pixels are shrinking, and if we use a smaller radius of this structure element, for example 5, so we have the result in the bottom left here, which we can see that the white is not as small as when we use the disc of radius 10. Okay, like the top right here, but it is the effect of erosion is much more less when you use structure element of radius 5, this shape. Okay, now what happens when we use much more significant or larger radius of this structure element, which is 20? Now we can see that the white pixels become very less, and at the border, okay, it's gone already. At the border, we now have only white pixels in the middle, but the size is very much less compared to 5 and 10 radius of this such element, which you have seen on the top right here and bottom left here. So these are the effects of erosion when using such element of this shape with different radius sizes. So to further understand what is erosion for, we now look at this example. If we have two objects which are touching one another or combined, okay, like this one, and we want to split it, we want to separate it so that it is separated, they are separated, so we can use erosion for that purpose. And the result of erosion on this type of problem is this one. So we have a clear separation there. So this is maybe useful when I want to do tasks like for counting objects and etc. Okay, and for the second case below, we have object with some intrusion, what you call intrusion, which is imperfection here. And again, erosion is useful to remove this extrusion, which can produce the output like this one, which have a much more cleaner shape of the objects. And so in conclusion here, we can say that erosion shrinks objects, and this is useful for splitting apart joint objects and also to remove extrusion. Okay, in dilation, okay, dilation of image F by structuring element S is given by F plus circle S. And again, F is the image, S is the structuring element. The structuring element S is positioned with the origin at XY. And the new pixel value is determined using the rule. The output or the process image contains the process pixel GXY. GXY will equal to 1 if S hits or fits F. Okay, it will be 1. GXY will equal to 1 if S hits or fits S. Okay, and GXY will equal to 0 if otherwise. Okay, now we want to know how dilation works. This is a practical example of dilation. So we have the same situation like the erosion example last time or on the last slides. So we have the original image on the left and process image on the right. Where in the original image we have objects, or in other words on pixels, or in other words pixels with number 1 in dark colors. Okay, now we have the structuring element, which is the same as the erosion example. And our rules here, we need to remember that we will give 1 if fit and give 1 if hit, but give 0 if miss. So now we start by putting the structuring element, the center of the structuring element, on the first pixel on the top left there. Okay, now we have miss. So if miss, so we need to put 0 here. Again miss, 0. Now we have hit 1, hit 1, hit 1, miss 0, miss 0, miss 0. Okay, then the next line we start with a miss, miss again, sorry, now we have hit, so we need to change to 1, hit, 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 miss. Okay, going to the third row, we start with miss, 0, hit 1, hit 1, fit 1, fit 1, hit 1, hit 1, miss 0. Okay, next row, hit 1, hit 1, fit 1, fit 1, hit 1, hit 1, miss 0, miss 0. Next row, hit 1, hit 1, fit 1, hit 1, hit 1, miss 0, 0, and 0. Hit 1, hit 1, hit 1, hit 1, hit 1, miss 0, 0, 0. Okay, next row we have miss 0, hit 1, hit 1, hit 1, miss 0, 0, 0, 0. Then we have 0, 0, 0 because of our miss, so 0, 0, 0, 0, 0. So as you can see that the object image or the object pixels of the on pixels, which is numbered with 1, is increasing, okay, compared to the original image. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So we have 33. If this is correct, so we have 33. So but the original pixels, if we can count, so we have, okay, 1, sorry, we have, okay, 1, sorry, 1, okay, we need to change to a color, and this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's 17. So 17 increasing to 33. So this is the effect of dilation to the object's pixels on the original image. And when we change those pixels with 1 in the processed image, okay, with color, what happened is that okay, we change the one with, okay, the extra one with, okay, green. You can see here, green, 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 and then there are other greens as well, but the original object with one we remain or maintain in blue pixel, and we can see that, okay, there is a clear increasing of size or expanding of object size, okay, compared in the compared to the original image. So this is the original image, small, but now we have a bigger object in the process image. And this example of relation original image using dilation by 3 by 3 and then dilation by 4 by 5. So the larger the size of the square structure element, the thicker the A line is. Again, one refers to the black pixels. And other examples, we have the original image, which is not very clear, and then after dilation we have much more clearer, okay, text. Okay, this is using the plus such element. And what is dilation for? So if you have, okay, dilation can repair breaks. So if you have break like this, so after dilation the break already gone, so you already join the the breaks have been gone, and the object already joined together. And if dilation also can repair intrusion. So if you have initially something like this, intrusion, it's like a hole, which is not very smooth over there, and after the dilation we have a much smoother circle. So dilation enlarges object.